Pell's equation from number theory. He's a British guy who apparently didn't have much to do with this. Now, Pell's equation itself, I believe, has a 1 right here. And it's very interesting all by itself. But this is something similar to it, but it's not the same thing. Some similar ideas. Now, you have 1,024, and I'm giving you that's equal to 32 squared. Okay? And we're also looking at just positive rational solutions. Now, those of you who've seen the Pell's equations, you're always looking for integer solutions. In this case, we're actually looking for a rational solution. So x and y, and we'll just go ahead and make it positive just to cut down on the amount of work. It's not much, just double the trouble for the negative side. So anyway, y'all, what we're looking for is numbers in the positive rational number field. That means Q plus, folks. Fractions, positive fractions. Okay, let's go down. Now, so this form down here, I've rewritten it. Here's the original equation right up here. And then what I've done is I've written it as the difference of two squares down here. Now, you'll notice this is in the form a squared minus b squared is equal to a plus b times a minus b. And of course, 29 is our constant here. And this sets up a nice little system of equations. 29 is prime, and so it only has 1 and 29 as its factors. And so you can just equate the corresponding factor pairs. In other words, you can set this factor pair, you can set this factor equal to the factor 29 from 29, and then 1 is also a factor, so you can set x minus 32y is equal to 1, okay? Now, you can see very quickly that if you add these two equations together, the 32y term eliminates, okay? And so you get x plus x is the 2x you see right here, and then the 29 plus 1 gives you 30. And of course, this indicates right here that x is equal to 15. Now, x is an integer, but it's also a rational number, and it's positive, right? So x equals 15, okay? Now, the instructions led on that we're looking for a rational solution, so let's see if y turns out to be rational. Now, right here, if x equals 15 in this very first equation, you could put it in either place. But notice right here, if you put a 15 right here and subtract it from 29, you get 32y. 32y equals to 14. Equals 14. Okay, and then folks, if you divide through y is equal to 32 over 14, or 14 over 32, excuse me. Y is equal to 14 over 32. And it looks like that fraction does reduce to 7/16. 7 over 16. And so we do have an ordered pair solution. First coordinate, x equals to 15, right up here. A rational number, albeit boring, it's 15 over 1. And then y is also a rational number, a real live rational number, some might say. A member of R/Z, I guess. So there you go. That is the solution. Now, you may say, well, aren't there more? Well, there is another possibility, but notice you could equate, you can reverse the factor pairs. That's totally legitimate and actually necessary. But notice you'd go through the same process and you'd still get x equals to 15 down here. Okay, x still is equal to 15 no matter whether we reverse the factors or not. When you go through the same process of adding, the 32y's will eliminate and you'll still get x equals 15. But that implies without doing any more arithmetic that y would be less than 0, right? And it's actually just going to be minus, I'm actually going to more trouble than it's worth. It would just be minus 7 over 16. But this does imply that y is less than 0, right? So again, I went to more trouble than it was worth just not to do it. It's very clear that the solution here would just be minus 7 over 16. I could have just worked that problem, you know. But anyway, we'll stick with the instructions. So we would have a negative y solution here. So we skip that and we just stick to 15 and 7 over 16. as the solution to this original equation. Okay, notice we don't even have to check it. The computation would be rather nasty, you know. Let me write it here. We did get x equals 15. X equals 15. And y is equal to 7 over 16. Let me check. So we got, yeah, 7 over 16. So y is equal to 7 over 16. And that meets the criterion, or the instructions that were called for. It would help to leave the equation there. And again, it'd be kind of a pain, I think, to check this, wouldn't it? 7, 16. Maybe not so bad. Maybe not so bad. Things would cancel out nicely, and you would get the 29. But anyway, I hope you guys enjoy.